can start again. So let's go ahead and build, look at the documentation. So this is the most important part of it. So there's two links in here. First is the API, and the second is the tutorial, which we care about. So the API is basically the list of everything you want to look at, of all the classes they have in here. Really, of course, what's important is the graph class and then the undirected sparse graph. Undirected, of course, meaning that it's also the sparse graph is just perfectly fine, I'm sure. But the undirected sparse graph, right? Undirected meaning the edges are, bidirectional. If you want it to be a directed, then I think you just use sparse graph instead. Or directed sparse graph, rather. Okay, use directed sparse graph if you want a directed graph. And as you can see, it holds vertices, which are a map of vertices to a list of vertices. Sorry, vertice edges pairs, and then edges. And it just tells you all the methods you can do. You can add edges, you can add vertices, you can ask if it contains an edge, contains a vertice, you can find an edge that exists between two vertices. You can get all the edges in the graph, you can get all the vertices in the graph, you can ask how many edges are connected. How many of these things are connected? So this is a good resource to look at if you don't know how to do something, because the answer is most of the stuff is probably already programmed for you that you want to do. So you need to download them, and once you've downloaded and get set up, you can follow these things. So a graph, the main thing you're going to be using is the interface graph vertice edges. It defines the basic operations. You can add or remove edges and vertices and get all the edges and all the vertices. You can get all the information concerning endpoints of the edges and get information about the vertices. And then there's other related interfaces, which are directed graph, undirected graph, and simple graphs. Right? We're just going to be using simple graphs that don't have parallel edges, meaning that you can't right? We're only talking about relationships that either exist or don't exist. You can't have multiple relationships with a single vertice. So let's look at this. So let's grab this code and just paste it in and see how that goes. Okay. So, okay. So graph VE is where V is the type of the vertices, and E is the type of the edges. So here, the first line, we are going to create a, you know what? I can do this. I think I'm going to do this myself. So I'm going to create a new undirected, it's already populating it for me, sparse graph that uses integers as the vertices and strings as the edges. Okay? That's all you need to do to create a graph. And now to populate it, I can add vertices. G.add vertex. So let's add the vertex 0. Let's add the vertex 4. And let's go ahead and add an edge between 0 and 4. G.add edge. So it says, so we need to give the edge a name so that we can refer to it later. So we'll call this one, I'll call this one 1, 4. I know that doesn't really make sense, but I'll call it 1, 4 because it's an edge from 1 to 4. Sorry. I'll call it 0, 4. Right? Because it's an edge between 0 and 4. 0 and 4. So now, let's go ahead and print out our graph and see what we get. So, Sout G, and it says that we have the vertices 0 and 4, and we have an edge 0 called 0, 4 that goes between 0 and 4. I could also just call it edge A, right? Instead, it would say there's an edge called A, and it goes between 0 and 4. Also to note is that you can do G.add edge. So let's add an edge B between nodes 1 and 3. Note that we haven't created 1 and 3 yet. But this is a very smart program. So it says, if you're creating an edge between 1 and 3, that means we have to create edges 1 and 3 to go along with it. So it created the vertices the edges. You got to create the nodes 1 and 3 to go with it. So it went ahead and created the nodes 1 and 3 to go with it. So you can add your edges, you can print them out. Let's see, what else can we do with this? We can g dot get destination, get the out edges, vertice 4. So let's go ahead and connect to g dot add edge from, let's call it C, from 1 to 4. Okay. So now I'm going to print out the out edges of 4. That means the number of things, the edges that go out from 4. It's also the same in an undirected graph. It's the same as the things that go into 4. So the out edges, it doesn't tell you the out number. It says these are the edges that are connected to 4. Edges A and edges C. Right, the names. It doesn't tell you what nodes I'm connected to. It just tells you. What you're going to want to use in a later homework is something like out degree, which tells me the number of the number. Or let's see, is that even in the interface? I don't think it is. So g dot Nope, it's not in the interface, but it's in one of these subclasses if you want to use it. But anyway, this is this is pretty nice. Okay. You can also create your own. So one thing to know about Jung, though, that's a bit finicky. Say I add an edge, also called C, from 1 to node 5. It's going to hate that. It's going to actually crash, saying that you've already created an edge called C, and it exists between 1 and 4. You can't create another edge named C as well. So the other thing you might want to do is create your own node class and your own edge class if you want to. And this is useful if you want your edges to have actually have a weight, right? It doesn't care whether you have a weight or not until you actually add them. Now the fun thing about these things, though, is that you can add. So we can let's see. We can print these graphs out. You can you can draw them and make them very pretty looking. And that's really why I was attracted to this. So you'll need to, let's see. So you'll have to follow these obtuse instructions, which are pretty terrible. But this is a program that will do everything but create the graph over here. So I've created the graph. And now if I copy and paste this code in, which is something you'll have to do as well, it will have something called a simple graph view. Let's see. Do I have that? Simple graph view. Something I've done before. So simple graph view. That should be something that I should be able to import. Yep. Layout. So import layout, import basic visualization server, import JFrame. So that's all that stuff. Import the dimension class. I'm just doing that with Alt Enter. Is there no dimension? Let's see, what am I missing? Basic visualization server from the graph. I should be able to import all the stuff. So why isn't it seeing it? Oh, there we go. So graph.visualization. So where is simple graph view supposed to be located? Simple. So the question, of course, is this the code messing up, or simple graph? Okay, so it doesn't like that. Oh, I see. it's saying that yeah, I don't need that. It's the file is called simple graph view that they were using, so there's no need for that. So I'll just see. So I don't need that. So circle layout, we'll pass it G, and then we need to import that. Import the class, and dimension, we're going to import that, and now we should be able to run this. Let's see, where was the, oh, right, we still had the error that I introduced, which was adding a edge that didn't exist. Sorry, that was already named. So now we draw it, and voila. So I just had to delete the first line from that code because I didn't need it. And there, it drew a graph for me in a circle layout, right? There's different types of layouts, but it automatically drew that for me. Notice that it's unlabeled and everything's red. That's actually possible stuff you can change in this. And that's pretty cool. But I mean, that's stuff that's neither really important for that. But you can follow the code along, right, and learn how to, create and display a graph yourself. So rather than having to rely on the fact that you're doing everything right by like trying to, using this, you can print the graph and go, okay, that looks right. You can actually have it show up visually for you. And all you have to do is just follow the tutorial. All right. So let's talk about the way that that graphs are represented internally. So there's the adjacency list. Let me draw a graph on the board. These things are easiest, of course, to do if you already have a graph that exists. So adjacency lists look like this. So suppose I have a graph A, B, C, and D. Okay? An adjacency list might look like this. If it's stored like this, it will essentially be an array of, one each. What we do is that we basically store everything in a map. Okay? So the vertices are stored in a map. And the key is the vertice. So key, vertex, and then the value is the list of all the vertices that I'm connected to. A list of adjacent vertices. So A would have B. B would have A, C, D. C would have C. C would have B and D, and D would have B and C. Now, if we were to turn this into a directed graph, and I'll just do it and I'll just make it simple. Everything's bidirectional here except for, technically I should have two edges here to make it easy to see. So everything's two-way except for A to B, and now what all this would be is that B would no longer have a C. B would no longer have an A variable because we can't get there from there. Okay, so that's the norm. That's one way to represent a graph. That's an adjacency list. Where basically for each node we keep track of all the other nodes it's adjacent to. The other way to do it is an adjacency matrix, which is exactly what it sounds like. It's a matrix. Okay. And it's all possible combinations. Sources over here, destinations on top. A, B, C, D, C, D. Obviously, this gets stored as a 2D array. All right, for an undirected graph, what we're going to do is that if you can get from this node to this from this source to this destination, we put a 1 there. If you can't, if they're adjacent, you put a 1 there. You put a 0 otherwise. So here I'll just leave it blank for 0 for right now. Okay, so you can get from A to B. You can get from B to C and B to D. You can get from C to B and D. And you can get from D to B and C. From D you can get to B and C. Okay? So that's an adjacency matrix. And we use ones rather than trues and falses because if you take this, you can actually do some interesting stuff with matrix multiplication if you need to. But suppose these things have weights. So like 5, 7, 0, 2, 1, 6, 4. So instead, we would put the values in. So you can get from A to B with a cost of 5, from B to C with a cost of 7, and from B to D with a cost of 6, from C to B with a cost of 0, C to D with a cost of 1, and D to C with a cost of 2, and D to B with a cost of 4. So now we run into a problem, which is kind of the reason why I didn't fill in these blanks yet. This was a free transition, essentially. You can get to C to B with a cost of 0. You can even have negative weights if you want to, and those mess things up like crazy. But if you can get to C to B for free, for 0, then we can't use 0 to represent the fact that there's no edge. So instead, when we're using weighted graphs, to represent that there's no edge between them, we'll actually use positive infinity. To say, yeah, you can get to from A to A, or you can get from A to C if you pay me an infinite amount, right, of money or something, or if you pay me an infinite amount of energy, right? So we use positive double dot positive infinity as the value in those cases. So we'll go back when we want to go back over this again. So I'll go back to this when we get back on Monday. But I want to talk about the 2 algorithms that you're going to have to do for Thursday and Friday, which is the 2 traversal algorithms that we've already learned in class. You're just going to do them now for graphs over the next week. Okay, so first is breadth first search, right? Everybody remember breadth first search? We start with a node. So to do breadth first search on a graph, the way it works is that you start at a node. Then you check all the neighbors, and then all the neighbors. Then you check all of those neighbors, and then you check all those neighbors. Doing breadth first search on if you're searching to see if two people are friends, or if there's a path from one person to another person on a social network, like because if they're friends or using the friends of friends, then you'll want to use breadth first search. You want to first start at the first person's friends and then search out from those friends of friends, then the friends of friends of friends until you hit that final location. Depth first search, on the other hand, basically says search as deep as you can until you hit a dead end and then backtrack. So let's look at the way breadth first search works. An example of breadth first search. Right? So we'll start at 0. We'll identify the start node. And when you visit it, we identify what it's adjacent to. And I'll probably give you until, not next Monday, but I'll give you until Monday instead of Saturday to finish this, because I'll have to finish up the instructions on Monday. So give you more time, but I want to make sure you guys can also have the time to make sure you guys can actually create a graph using the program of your choice. So breadth first search, the way it's going to work is that we mark the start node. Okay, we identify the start node. And then we're going to look at all the nodes it's adjacent to and mark those as things we're going to visit. So we start out by visiting 0, then we look at our adjacent nodes and we throw them into a queue. So we throw 1 into a queue, then we throw 3 into a queue. We're done visiting 0, we found all its neighbors, and then we go to the next thing in our queue, which is 1, and so we visit 1 and we look at all of 1's neighbors, which are 2, 4, 6, and 7. Add all those nodes to the queue. We're done visiting 1, then move on to 3. Visit all 3 neighbors. We've already seen all of 3's neighbors, so we don't add any of them to the queue. So we're done with 3. Next is 2. Add 2's neighbors to the queues. And then then we're done with 2. Then we visit 4 next. Add 4's neighbors to the queue. We only add the stuff we haven't seen yet. We don't add anything twice because we don't want to visit anything twice. And we just continue until we visited everything, until the queue is empty. So, let's see. It is 1:40, and honestly, this is a pretty good stopping point. And my voice is kind of getting to the point where it really needs to recover because, yay, recovering from a cold while having to do lectures. So I'm going to enjoy being able to be silent for a couple days. All right, so, all right, I think, and I'm sending instructions on you. So your TA should be working on grading the exams by tomorrow. So that's when they're supposed to grade your exams, and then they'll hopefully be able to hand them back to you in the Friday lab if you're Friday. Otherwise, you can come and see me to get them on Monday. So, but you will get your grade posted as soon as they're graded. And if you